Hello class, welcome to Geometry Lesson 10.1, which is all about arcs and sectors of circles. By the end of this lesson, you should be able to find arc length and sector area of a circle and use them to solve problems. Let's start by looking at example 1, which is all about relating central angles and arc measures. So what are the measures of arc AB and the measure of arc ACB? Now if we look at this circle, if I just said, what is the arc of AB? Some of you might naturally go straight from A to B. Some of you might have said, well, I can go from A to B this way. And technically, you're not wrong. You do get to AB by going along the green line. But in order to get to AB on the green line, you also go through point C. So that arc is now ACB. Okay, so if I said what are the measures of arc AB, I would start by just going from A to B, and the measure of that arc matches the interior angle here, the central angle. And so that is going to be 95. What's the measure of arc ACB? So for ACB, I go from A to C and from C to B. And the measure of that would be the rest of that circle, right? How many degrees in a circle? 360. So if I do 360 minus 95, I'm left with 265 as my arc ACB. So those are my two answers. That's all you have to do if I'm asking for the measure of the arc. Why don't you go ahead, start with letter A. What is the measure of arc XZ? Good luck. Hopefully for this problem, you said the measure of arc AXZ is 115. Next, I want you to find the measure of arc XYZ. Good luck. Hopefully for the measure of arc XYZ, you ended up with 245. The way you got 245 was doing 360 degrees in the circle minus the 115 to be left with 245 degrees. Now some vocab for this lesson. You've heard me already mention one of these words, central angle. That's the angle that they give you. So right there, APB, angle APB is a central angle. It's the one that we're talking about, we're looking at. And arc AB is formed by that central angle. So the part of the circle that is between those two sides of the angle, that forms our arc. Then, another important piece of information is a minor arc. Now, a minor arc is any arc that's smaller than a semicircle. If you've forgotten what a semicircle is, it's 180 degrees because it's half of a circle. So that means a minor arc is going to be anything less than 180. A major arc is any arc that's larger than a semicircle or greater than 180. I don't know why my pen changed colors, but a major arc is greater than 180. All right, let's look at example 2, relating arc length to circumference. So how do you find the length S of an arc measured in degrees? So if we look at this circle, we have the measure of an arc is a fraction of 360 degrees. 360 would be the entire circle, right? We know there's 360 degrees in a circle. So our arc length is just the little portion, oops, I erased too much, that forms our arc. So it's a fraction of the entire circumference. The circumference is around the outside of a circle. So we can write it as the arc length over the circumference. Then the arc length, the way that we can solve for that is we take the arc measure, so whatever angle that central angle is, excuse me, we put it over 360 degrees because it's whatever that angle is over the entire circle. So we do arc measure over 360. So if we fill in with some variables there, we would have S over 2 pi r. And 2 pi r is how we represent our circumference. If you've forgotten what circumference is, it's the distance around the outside of the circle. And we set that equal to n over 360, and n represents whatever our arc measure is. So the formula you need to memorize is S, or arc length, equals n over 360 times 2 pi r. Okay, we're going to use that on the next question to solve this problem. So in a circle with a radius 4, what is the length of an arc that has a measure of 80? Round to the nearest tenth. Starting with our formula, the arc length equals n over 360 times 2 pi r. Now let's fill in the information that we know. We know we're solving for the arc length. We know the measure of our angle is 80. And we know what our radius is. Our radius is 4. So I'm going to do 2 pi. Instead of writing r, I'm going to write 4. Now I can simplify this by saying S equals, if I simplify 80 over 360, I get 2 over 9 times 8 pi, because I can do 2 times 4. So S equals 2/9 times 8 pi. If I multiply those two numbers together, 2/9 times 8 is 16/9 times pi. And in this lesson, you're going to learn something called exact answer. If I ever ask you, or the book ever asks you for something called an exact answer, this is what we're talking about. We're looking for this, meaning you don't actually have to type that into the calculator and figure out what that decimal is. However, in this example, it asks us to round to the nearest tenth. So on my calculator, I'm going to type in 16 divided by 9 and then multiply by pi. Now, moving forward, you need to use the pi key. I do not want to see you guys doing 16/9 times 3.14. I don't want you guys rounding that off anymore. You need to use the pi key. So 16 divided by 9 times pi. And if you do that, you end up with 5.6 as your answer. Okay, so this would be an exact answer. This is my answer rounded to the nearest tenth. Okay, next we're going to talk about something that isn't degrees. Up to this point in your life, you've only ever worked with degrees. You've never learned about something called radians. Radians get easier to use the farther into math that you get. So today, my goal is just to introduce you to what radians are. We're going to do the bare minimum. So that way, when you get to Algebra 2 or trigonometry and you're working with radians more, it's not something that's totally new, okay? So if this is a little confusing, that's okay. When I learned radians, I was confused at first too. So make sure you ask questions. It's okay to be confused as long as you do something about it. Okay, so how do you find the length S of an arc measured in radians? So the way a radian works is we have our radius, and 1 radian is when your radius and your arc length are equal. So as long as those two distances are equal, this angle in here is 1 radian. So this radius could be 5, and this arc length could be 5, and this would be a measure of 1 radian because my two numbers are the same. So that means if this radius is 2 pi, because sometimes we put pi in there, and this is 2 pi, my answer is 1 radian, okay? So as long as the radius and arc length are the same, you have 1 radian. Okay, there's a lot more information here that you can read through. However, I'm going to do some problems that I think will maybe make a little more sense for you guys. But before I move on, I want to introduce something called theta to you. It's a Greek letter. It's a variable often used for angles that are measured in radians. So you'll see it looks like a circle with a horizontal line through it. So in the past, you guys have seen things like that. This symbol down here means no solution or null set. This up here, that slight change, makes it theta instead of null set or no solution. So you need to take the time to make sure that you are drawing the correct thing on your sheet of paper, okay? So theta is what we're going to use with radians instead of like x. okay? The last thing you need to know is to find the arc length. You do theta, which remember that's our central angle, times the radius, okay? So you need to memorize the arc length for radians is theta times radius. Now, in this question, I'm going to actually just do this one for you guys, and then I'm going to have you solve one later on, okay? So in a circle with radius 6, what is the length of the arc? So I want to know what is the length of the arc that has a measure of pi radians. So instead of writing like 80, like the last question that you guys did, I'm giving you pi. Okay, so we know S equals theta times radius. So S equals, my central angle is a measure of pi, so I'm going to write pi there, and then my radius is 6. So my arc length, if I asked for an exact answer, I would just write 6 pi, because we usually write numbers first and then symbols second. So if I asked for an exact answer, this is what I would write, and I would be done. I wouldn't even have to type that in. But we're not asking for an exact answer this time. We're asking for a nearest tenth, so I'm going to type in 6 times pi, which is approximately 18.8. And I'm going to remember to use the pi button instead of typing in 3.14. And maybe you typed in 3.14 and you said, I ended up with the same answer. That is because we're rounding to the nearest tenth. If I asked you to round to the nearest hundredth, the number changes. So you do actually have to use the pi key. You can't just be like, ooh, I'm being sneaky. Miss Johnson will never know if I use 3.14 instead of the pi key. Trust me, I will know. And you will not like your resulting grade. So, arc length. This is the summary of it. If we're working with degrees, this is your equation. If we're working with radians, this is your equation. Make sure you have those memorized. This is a great thing to take a screenshot of. And let's talk about applying the arc length. So we are using Circle Q, and we are expressing answers in terms of pi. When I say express answers in terms of pi, that's another way of saying I want the exact answer. I don't want you multiplying by pi and giving me a decimal. Okay, so what is the length of JK? So I start over here at J, I move to K, and I know I'm not going the other way because that would have to be JHK. So I'm just going to do JK, and I see that it's radians, so I'm going to use arc length equals theta times radius. So my theta is 3/4 pi, and my radius is 5. So what I'm going to do is I'm going to multiply my two numbers together. So 3 times 5 is 15/4 times pi. And that is all I'm going to do. I'm not going to multiply it out because we're looking for an exact answer. So I solved JK for you. I want you guys to find what is the length of JH. Good luck. Hopefully for your answer you saw that the central angle was 1/3 pi and the radius was 5. So you multiplied the two together and got 5/3 pi. Now I want you to solve this problem. This one's in degrees, notice. And same as last time, express the answer in terms of pi. Good luck. All right, for this problem, hopefully you saw you were solving for arc AD, and you saw that we didn't know what that central angle was, so you solved for it by doing 360 minus 104 minus 73 minus 43 to get a central angle of 104. And then you plug that into the formula that we have. You said the arc length equals 140 over 360 times 2 pi times 4 was our radius. Once you simplify that all the way down, you get 28 over 9 times pi. And that's all you have to do because I'm looking for an exact answer instead of a decimal. Let's talk about areas of a sector. So the sector of a circle is the region bounded by 2 radii. So remember, radii is just plural for radius. So we have 2 radii, one here, and it's the area between them. So instead of finding the area of the entire circle, I just want that small portion. So like if you wanted to know how much pizza you got out of an entire pizza, you'd be finding the area of a sector, okay? The way that we find this is you still use that fraction, so you use that angle over 360 because that's the portion you're looking at, but instead of multiplying by the circumference, we multiply by the area of the circle, so that's pi r squared. So in this case, we have a radius of 10, so we would do 10 squared. So we have 78 over 360 times pi times 10 squared. And once you simplify that down, you get 65 over 3 times pi, and you label it with centimeters squared. And that is how you're going to find that answer. I want you to go ahead and solve this problem on your own. Good luck. All right, hopefully for this problem, you plugged in 165 in the place of n, and you plugged 3 in for the place of r. And once you simplified that, you should have ended up with 33 over 8 times pi as your answer. If not, please be sure to reach out for some help. And our last example is finding the segment of a circle. So we've talked about the sector of a circle. That was when we had an entire, like piece of pizza. But now basically the segment of a circle is you only want the crust. You don't care about the rest of the pizza. You just want to know how much crust am I getting, okay? Apparently Miss Johnson's hungry because she's using food analogies. But hopefully that'll help you remember the segment of a circle. If we look at this problem and we want to find the area of that shaded region, so like that piece of pizza, the way that you're going to find that is you would take the area of the whole piece of pizza and then you would just subtract the area of the non-crust. So you find the sector, like what we just did, and then you subtract the triangle portion. And that gives you the segment. So let's start out by finding the sector. So our central angle is 60, so I say 60 over 360 times pi r squared, and our r value is 8. 8 squared is 64. If I multiply 60 and 64 and then divide that by 360, I end up at 32 thirds pi is my area of the sector. Now the triangle is where things get a little trickier, but it's nothing new. So we have this triangle. We know that this is 8. We know that this is 8. We're cutting this in half. So if I had 60 degrees here, I now have 30 degrees up top, 60 degrees down here. I have a 30, 60, 90. And I realized I didn't say why I did that, so hopefully you remember. But if you don't, quick refresher, the way you find the area of a triangle is 1/2 base times the height. So I have to figure out what this height is. So if I have a 30, 60, 90, and I remember my special equations, the special relationships, I know that the hypotenuse is twice the length of the short side, so this is 4. And I know that the long leg is the short leg times the square root of 3. So I know the height of my triangle is 4, square root of 3. So I'm going to say area equals 1/2, and then I'm going to come back to the base in just a second, 4 square root of 3. And I found that this part was 4. That means this part's also 4 because I cut it in half. So my base is a total of 8. So 1/2 times 8 is 4 times 4 square root of 3. 4 times 4 is 16 square root of 3. That is the area of my triangle. So I'm going to say minus 16 square roots of 3. And when I plug that into my calculator, I end up at about 5.8 centimeters squared. If I round to the nearest tenth. Okay, so find the area of the sector, find the area of the triangle. It involves you breaking it up into smaller triangles to find your height. and then subtract the triangle from the sector, and that gives you your segment. So think of it, sector's the entire slice of pizza, triangle is just the toppings part, and segment is the crust. Why don't you go ahead and solve this problem on your own? Good luck. All right, for this problem, hopefully you found the area of the sector to be 25 pi and the area of the triangle to be 50. If not, please be sure to reach out for some help. When you subtract those two, you should have ended up at 28.5 feet squared. Just as I've been saying forever since you guys have had me, make sure you ask questions if you're confused, and I'm more than happy to help you. And here's your concept summary, a great thing to take a screenshot of to help you remember some of these terms and formulas. Have a fantastic day.